G'day, welcome to Edington Machine Works. My name's Adam. I'm making some hubs, drum brake hubs to be quite precise. Instead of using expensive Sturmey Archer drum brakes, I'm going to be using cheap postie bike drum brakes, which are larger, which should hold the larger braking loads from the larger diameter wheels, 28 inch roughly. These are 70 mil for 20 inch drums, 20 inch wheels. So it's the same setup as the hubs. You got a boss with a bearing in it, except this is a bottom bracket bearing which is threaded. This side's left hand, 1.37 by 24 TPI, and I'll have the drum itself, the steel drum, secured with 6 bolts. There and whatever. But there's going to be a few other differences. Instead of having one bolt to hold the braking loads, I'm going to copy a disc brake which has 6 bolts at a PCD of 44 millimeters, and these are M5 bolts, and I'll go for M6 bolts and have 6 of them at the same PCD, and add some hexes and flats, and that should be a bit more solid than just 6 M5 bolts. Furthermore, I've machined the spacer, this little spacer here, into the kingpin itself, and instead of a press fit onto the nose of the kingpin, I've got my hexagonal bolted fit, and I've machined the thread for the axle into the back of the kingpin itself, so I don't have to worry about another nut that can drop off. This is a left-hand axle, so I've gone with a left-hand thread, and this is where I stuffed up. 120 millimeters there. This is 140, 6 mil wall thickness, and I had the spoke flange too close to this edge, too close in the vertical axis, so that machining my 120 millimeters for the labyrinth seal into the base of this root, base of the root diameter of the spoke flange would weaken it too much. So I'm going to shift that spoke flange down by up to 40 mil. I'll decide later. I've got my 5 mil gap there for the root diameter of the labyrinth seal. Then I'll put the spoke flange somewhere out here, and then turn the profile of the hub, which is that profile. And then I'll thread that end. So I have to bore this out to 33.74 millimeters as the root diameter of the bottom bracket threads, and then put a right hand thread in this end and face it off to length. So I'll come back when that's done, but as you can see, I've got it running within O1 plus noise. Boring it to diameter. So I'm just about to touch off here, and watch for the line that will appear as it first touches off. There. Okay, so I landed at 3.2. This will take me up to 4.2. Try and land on 5.0. Engage the feed. Add some coconut oil to it. We landed on 5-2, 5-1, 5-2. There, that's catching. So, final cut. Find the centre between that extreme and that extreme. There. Pull forward. Find the highest dimension. (7.5). 0.2 different. Sorry, 0.1 different from our target, which was 7.4. And we're good. Next up, threading. Okay, so I've made my first scratch pass. Set it to 0. Now I'll take a cut of 0.1 and start it going. Lead screw's going the right way. And I'll go till this is about 1 millimetre from that face. Give myself plenty of thread. Because I'm doing right hand thread, I've slowed it right down. If I was doing left hand thread, I could go a lot quicker. Go. Disengage the half nut. There. Take it back out and reset. So we're at 0.45 depth of cut, and we're just starting to get our thread start to engage. So I'll take it out to point. That's where we were. Okay. Okay. Now let's wind ourselves back to engage. Okay, so that was depth of cut 0.55, and we are threading in, although it is quite firm. So I'll do a spring cut at 0.55 to 0.58. Coming up right now, 0.55, 0.56, 0.57, and engage on 0. So we're at 0.57 now. And I'll come back when we're ready. Screws in nice and freely with no slop. I don't have to struggle to thread that, but I can't feel any slop. Oh, it's about 0.01 slop. Job done. Okay, so I've taken it over to the rotary table after I've roughed out the profile to get some clamps on. I won't be worried about marring up the surface because I'll be actually taking this surface right down when I finish with it. It's just roughed out enough to still retain some rigidity while I do the milling operations on it, and take the rest off later. Anyway, so I've got this bearing dialed in to within tolerance, and now I have to take out this amount. I've also changed my mind. I'm not going to do J-stud spokes anymore. I'm going to do straight pull spokes, which will tie in a bit better with this diameter and the labyrinth seal up here, especially drilling all the way down. Anyway, so I'll rough out this section and then start roughing out the straight pull spoke bosses. Now, one thing with straight pull is you don't need as many spoke holes or spoke flangey things. Now what that means in this context is instead of having 18 holes on this side, I actually have 9 bosses to deal with. So instead of having to drill in pretty much on the line with the neighbouring spoke flangey thing, I'm actually dealing with that one to that one, so I've got plenty of clearance to drill that one because this one isn't here anymore. Neither will that one be there anymore, but that one will be. Delete, leave. So that just gives me extra room, and that will let me drill out sections there and delete a lot of weight that way. And I can just machine straight down to that diameter from the top, which will leave me enough room for the labyrinth seal to properly mesh, and the labyrinth seal only has to go down there, but the straight pull spokes will still come from down there, so it's actually not weakening it anything anymore. Anyway, that's the plan. Best laid schemes of mice and men. Okay, so I've roughed this profile out with the the ball nosed end mill, and I've roughed that diameter out, and so I've let it cool down overnight to get an accurate reading on this diameter, but I'll show you the drawing just so you can make sense of it. So this here is the brake plate from there to there, which corresponds to this piece. We've got a labyrinth seal groove, face groove, which corresponds to that one. Now, because we're dealing with 110mm drums, this is 110 minus. I've got a 3.5mm cutter, which will land this at 116 plus. Okay, so we've got a 4mm deep groove with 3mm of engagement, which means 3mm deep here on the steel drum. 1mm gap for the labyrinth seal. Then we've got our hexagonal protrusion, which is, come on, under there. That's 30mm across the flats, and it's 20mm from this face to the back of the brake plate. So 20mm deep. We'll go with a nominal 8mm, although this is actually a bit more than 8 and we've got a bit of meat to play with. So 8 plus 12 equals 20, and then we've got 25mm deep shoes on our brake pads from Postie bikes. So we'll give a bit of floor clearance on the drum, plus our 3mm here gives us a total of 30mm from there to there. And we'll leave 5mm for the countersunk screws. But for next machining job, we have to deal with 120mm, which is this diameter, 140mm, which is this diameter, and our 116mm, which is the outside of the groove diameter there, because we'll go for 3mm wall thickness on the steel drum. So that's 110 plus 3 equals 116. Do the math. Okay, so next is to take an accurate measurement of the bore on this, and I'll do it by verniers and then stick a micrometer across the verniers, the internal jaws of the verniers. The reason is because we've got a great big boss sticking out. Now this boss will have to sink back far enough to have the bearing facing seated on that face, but keep our 1mm gap there. So I'll have to double check the numbers, and the very last thing we do on this side will be to machine this face back, and we'll do a climb cut on the inside so as not to leave any burrs on the threads. So to do that properly, we need the difference between that face and that face. So I've got a depth mic, and it looks like we're 5mm deep from the top face to that face. Now we put a micrometer on that gap, and it's 3mm, which therefore means that face to that face is 2mm. We won't worry about decimal points because we've got an entire millimetre to play with in that gap. Which means that this face will be 2mm below that face. Which means, focus, that the depth of the boss, focus, depth of the boss here will be 10mm below there. Okay, so I've pressed this real hard and taken a micrometer measurement across the internal jaws of the verniers, and we're sitting on 0.5 under 114. We'll take it up to 116. Now, because we are going to take this surface down by 10 millimeters, I'm going to touch off here with the cutter and zero the dial and come down 35 mil in the center and leave space for a corner radius, and then I'll attack the diameter. Okay, so I've trimmed this down to 10 millimeters below that surface, and because I'm going to come in with a corner rounding end mill to take this sharp edge off, I can afford to touch my ball nose end mill off and set my zero there so that I can take this down, because this is now at final depth and I just need to get an accurate cosmetic finish there. It's not entirely cosmetic, it is functional. It takes out a stress riser. The other thing is, because I came from the inside and climb cut when I took this surface down, I got a very clean thread end and I could screw the bearing straight in. I've also left a little corner there for the corner radius, because this is now at final diameter, and I've also machined in the little step there for the labyrinth seal, which will be the outside diameter of the steel drum will be here, then the second lip on the brake plate will come here, and we've got clearance on this diameter. So when we take this out with a ball end mill, we will leave a bit of wall thickness and come into about there for our spoke bosses. Okay, now for the most critical corner radius. This corner radius here holds all the weight of the spokes bearing on the drums. Unfortunately, due to the fact that the steel drums has to bottom out on this face, this corner radius can only be a 5mm cutter, unlike here where it's a 3/8 cutter. But it really deserves the largest radius. It's unfortunate, but it's a design compromise. So I've touched it off there, because this edge is going to disappear, just like I did with touching off here, which is also going to disappear. And so then I will touch off on that diameter and gradually work it down to full depth, 0.5 mil per cut. I've also had to tilt the head over so that this part here doesn't ram into that. We've got a lot of run out on this collet chuck, so I have to do it by eye. I can't do it by numbers. Anyway, it'll be really noisy, up to 1800 RPM, so I'll bring you back when I'm done with that. Okay, so I've come out on the diameter, so that is smaller diameter than that, and I've gone 0.5 mil deeper than nominal floor diameter, just so I've got a full radius, and any chamfer or half radius that I put on the drum will actually bottom out on this surface. Now the final two details to put in before we move on to the spoke flange on this side is to take that corner off like I've done here, there, and then put in a small lead, and I'll do that with a ball nose end mill there. There's no need to put a lead on that. I will chamfer it with a 45, but this I'll put in something like a 30-degree lead so that it doesn't hang up and get jammed when I'm heat shrinking the steel drum into the aluminium housing here. Now I've just realised that with our 10mm deep bearing boss, I have to balance that with the gap here. Now I'm just not in the headspace to keep track of 20mm forward, 12mm back, 8mm back, 5mm down, 2mm back, 4mm down, 1mm back, 3mm up. Yeah, it's just a bit too much at this hour of the day. So what I'll do is I'll cut the drum slightly long and I'll tune the face back as custom fitted. Anyway. Right, so that's put a nice lead in on that edge, and I must give a big shout out to Phil from Diamond and Carbide Tooling, who gave me a really nice deal on this English rotary table. It's quite a beauty, so thank you, Phil. Anyway, next up I'll put a tiny chamfer on that and we'll get on to machining the edge. Okay, so we've given ourselves about 4mm wall thickness and given ourselves a nice radius that way. The next task is to give ourselves a nice radius that way on the walls of the spoke bosses. So the spoke comes in here, plenty of meat there, but we'll have to drill or use an end mill at that centre and that centre there, so that there's 40 degrees, which is 360 over 9, between each spoke boss and the next one. So I'll do it by eye as to that angle, but the centre line will be every 40 degrees. And then once we make these spoke bosses, and so we'll drill them down that way, drill them across for the spoke holes, and then trim them to length that way, so we don't want too much weight. As I said earlier, we've got plenty of meat to deal with. I've settled on 7 degrees either side of centre line, so there's centre line at 40 degrees, and that's the edge, that edge of 7 degrees, and that'll provide enough meat when we put our radius there and our radius there, enough thickness there to drill through for our spokes. Anyway, this will crank up to 1800 RPM and it'll be quite noisy. I've left just a tiny bit of a gap there, so we've got our 4mm wall thickness. That's 116 plus 4 equals 124, yes. And then a bit of a gap. Let's see what we are here. Let's make that a round number. Okay, clamp there. And we've got our centre line there, which is where the drill will hit perpendicular to the cut surface, and then we'll have 3mm plus a bit. Yeah, that's good enough. Okay, so that's our 7 degrees pair done. We'll take it round to 40, but 7 degrees shy of 40. Yes, lock up. Where's my pointer? Here we go. So we will eventually drill across there for spoke number 1, and across there for spoke number 2, and then put a matching radius to that down on that side and trim that down. We'll then drill here and then delete that much, and then delete that much around to the next one, etc, etc. Okay, so we're working down to depth, then slowly pull it out, and once we've done that we can then work our way back in and take out that in a climb cut very slowly so we don't break the cutter, and it looks like this. I've left a bit of extra diameter there to play with later on, just in case we need to deepen it to take out any burrs. Maybe I should go deeper and then not lose anything when we put the radius in. I'll decide later. Okay, so the next step is to round out that corner with a horizontal spindle, just like I rounded out that corner with a vertical spindle, but the only way to access it is here. We'll give ourselves enough meat for 2 spokes and go all around. I'll see you when that's done. Okay, so I only ran into the chuck once, as you can see from that little divot, and I've drilled the spokes at an angle. This will be the spoke end, that will be the button end, the rivet head end, and so I've come down for my second spoke hole, 5mm, and I'll repeat the process of spot drilling and then finish drilling, and then get back to you. Gonna get loud. Okay, so I've got a couple of J-bend spokes in here, just as a demonstration, but we've got a bit of a V between that and that. It's not quite straight pull, but I think that's actually good. The pictures I've seen on Google do have a bit of a bowstring in them, so I'm not too worried about that. When we come to deburr it, we will have to get a ball end mill in the drill chuck and take out the seat of the, just to cater for the countersink on the stud on the rivet head. Is it going to get loud? Nice. Okay, so I'm ready to flip it over, and when I do, I want to clamp on a nice machined face. That's not true to the face, but this is the face of the rotary table. Well, this is not guaranteed to be true, it's just come off the lathe. But this is machined true to the face because we're clamped directly down to the face there. So the next thing is, will this clear? And I've measured it, and this is 0.01 higher than that. So we're good to go, because I don't really want to clamp straight on a tiny thin sliver of aluminium. Now the fun begins. The issue here is that if we rotate this till this part is up against the high part of the stop, because we're doing 9 lugs, this is not contacting. To contact properly, it would have to be over there, which would shift this out of contact. So what I'm going to do is screw the old bottom bracket shell in and dial in on this face. Just lightly toe clamp it here and there, and then we'll dial in on that face and tap it round. It's a pain, but yeah, it's what you have to do. Okay, so I've put a witness mark in the middle of one of these and transferred it up to there using a straight edge and a hammer, sharp straight edge. I've dialed this in within O2. I put a 10mm cutter in, and then it's a matter of taking all this material out, and rather than turn it down on the lathe and waste all that material, I'll just turn this into an annular cutter by turning the rotary table and drop off a ring. And so because we had our 140mm here and our 124mm there, that gives us a difference of 16mm. I want a 45mm boss out of here. This is 1.37 by 24 TPI, and I want the bearing boss to be 45mm, plus our 16 gives a 61mm radius, outside, sorry, not radius, 61mm diameter. 61 divided by 2 is 31.5, plus our 5mm cutter radius, which is a 10mm cutter, gives us a X offset of 35.5 plus a bit, because we're not limited by the outside diameter of our billet. We'll give ourselves a bit of extra room to play with, and we'll go for a 40mm offset, which in theory takes it to 80mm. Sorry, 70mm, not 61. Okay, so this little line here is where the cutter breaks through. So I'll get this on it. Okay, nicely done, that's hot. Okay, so that's cleaned up that much. This will get taken out in the lathe after I've turned the spoke bosses down to there. We'll give ourselves a radius there and there just to delete some weight. Okay, so I've had to come in a bit narrower for the sake of okay, so I've turned this down a bit narrower so I can actually get my spoke in. As you can see, it's fighting. And we've also had to go for a thinner section here because we've got a smaller diameter than our 140 140mm spoke bosses there. Okay, so we're in the lathe now. We're only gripping on that, so we have to take light cuts. But I've centered in there. Come on, focus. And I've kept the steel threaded center just to stop things crushing. And now we need to turn this back to length that way. Put a shoulder on it, put a radius in there, and turn this down to 45mm diameter. I'll come back to you when we're ready. Okay, so I've installed the steel drums and put 6 countersunk holes in it and got the bolts in. There's a bit of extra left over, so I'll put some nuts on it. And that means this is complete. I've also put a corner radius on it. I will finish it up by hand just to take the fuzz off, and then it's up to spoking and lacing the wheels.